Testing. All right, I guess it works. He was kind and let me use this. So yeah, hi, I'm Tiffany Jernigan. I'm, I guess, currently between job things, doing developer advocacy. If you are at any of the other Devoxx is coming up or other conferences or want to see what other things I'm doing, you can just go to my website there. Or if you still use Twitter or X, you can find me on there as well if you have any questions afterward and don't get to ask either of us before you leave.
I work for a company called Novatech, where I mostly help people on their journey towards a cloud-native software engineering environment and culture, mostly on the focus of technologies and the way to adopt and to learn them. So yeah, I also still use that kind of dying bird network at the moment, but continuously having the transition to LinkedIn. So if you want to find me, either one of them should be fine. Anyway. We have a link to the slide deck, but you don't have to take the photo now. We have the link again at the end. So you can decide if you like the talk to download it then. I just want to make sure this is gonna be there. And also, we're a bit limited on time here with 40 minutes and we're going to show quite a few technologies. So this time will not allow us to go into depth in live demos, but we did a previous session with similar topics on this at Devoxx Belgium last year, where there is a 3-hour recording available on YouTube. So if you enjoyed the topics here and want to see something deeper, try to look that up on YouTube, and you can see more details there then. Yeah, so as I said, just a quick repetition. It's going to be about observability around Kubernetes, with certainly polyglot aspects. Some of the solutions are independent of programming languages and framework. For the ones that are, well, the Devoxx has a bit of a JVM flavor, and so we also focus a little bit more on Java or JVM-based technologies than others. All right.
So chances are that you probably already had some idea as to why observability is pretty important, which is potentially why you're here, or maybe you're just trying to learn more about it. But basically, I guess who here has used Kubernetes so far? All right, so a good chunk of the room. Yeah, so chances are, at least at some point in time, that you found that Kubernetes can be pretty complex. There's a lot of things that you have to understand of how things work. How are things working together? What are the different components? How's my application doing, et cetera? Basically, there's just so much stuff that is there, and you need to figure out potentially, hey, are things working the way I want them to, or is something going wrong, and how do I go about doing that? So our plan is to basically show you some tools that you can use to help make things a lot easier in that department. Obviously, there's so many tools that we can't go into, so we just picked some of them that we knew more about so far. And my clicker works. Thank you, Devoxx France. All right, so looking at this, you can see that there's basically 2 layers that we have here. So we have our application and we have our infrastructure. Before going and diving into things a little deeper, I'm just going to make sure to level set things a bit for Kubernetes to just make sure that everyone is kind of on the same page. But basically, you have a cluster, you have nodes, which is where all of your applications end up running. You could have one or multiple, depending on the level of high availability that you want. So basically, if we look just at the infrastructure, for instance, we have our control plane and we have our worker nodes. If you're using some sort of managed cluster, then perhaps you don't actually have direct access to the control plane, but maybe you can get metrics and different things with observability that the provider might end up giving you. So with this, one of the really nice things is that you can have a bunch of different languages. You can have different applications that are using entirely different languages that are still talking to each other. With these different applications, they might have different types of monitoring, and you basically might have interest in hey, what is happening with my workloads? Is everything working the way that I want it to or not? So observability can be pretty challenging. One of the reasons behind that is that basically you have your cluster, you have all these components that are in your cluster, you potentially have a bunch of different languages that you have, and then Kubernetes has its own set of API objects. So you have your deployments, you have your replica sets, there's a bunch of different things there that you need to understand how they're working and trying to figure out what their things are going the way that you expect. So just to kind of summarize a bit of that, basically you have all these different pieces, and not only do you have your individual applications and care about, hey, how is this application doing? You also need to care about, hey, is this application actually talking to this other application that I expect it to? And there's just like all these different things that we need to care about and decide like how are we going to go and observe these things. So this is one of the things that makes observability kind of tricky. There's just so many different levels that you can go and query on. So you can kind of see here, you can perhaps talk to the API server, you can figure out things from your node, your pod. There's just like so many things. So basically, these are places that you can end up putting agents at. So like for instance, we could have one with our API server. We could have one that is at the level of our nodes. We could end up having a sidecar that is running in our pod. There's also for the app itself. So basically, we'll be going through these different points of like collecting how to get data from those through this talk. So, and depending on like where you are specifically trying to collect metric data from, it'll give you different amounts of metrics. And not only is there a difference in like the kind of metrics that you're trying to get, there's also perhaps like a difference in price, whether that is actual cost, whether that's overhead. Maybe there's certain places where you don't have to worry about, hey, do I have to update my application, et cetera. And then there's times that you do rebuilding, et cetera. Basically, there's a trade-off, and you have to kind of decide, what do I actually need? So that's where a bunch of tools come in, because Kubernetes doesn't do all of these things for you. Basically, there is this, who here has seen this, I guess, older version now of the CNCF landscape? Okay, so not that many people, congratulations. But basically this is just an older version, but basically you can see that there's a bunch of different areas, there's storage, and then the one that we specifically care about here is observability. If we look into it further, which is a newer screenshot, basically you can see that there's just a ton of stuff there. There's different levels of like whether it's graduated, incubating, etc. And we're going to just go into a few of these in this talk.
All right, thanks. Yeah, as Tiffany just said, there's plenty of stuff out there, and we hope with this talk we can at least try to give you a bit of an idea on which tools kind of belong in which category, and what can you expect from the certain categories in a way that how much do you need to invest, and with invest I don't mean like money-wise, it's more like overhead, configuration, changing of software-wise, like how much impact does it have? And what can you expect as a thing in return? I mean, the things we're going to show are not necessarily competing with each other. It's more like to set some kind of boundaries and give you an idea what is actually possible with which level of depth of integration. So I'm going to start with the Kube API. This is probably the part that most of the people that have just raised their hands already kind of got in touch with. So this is the part where some kind of client software reaches out to the API server to query information. And the most popular one is pretty much like what people already know is the kubectl command. This is also just like a client that interacts with the REST API of Kubernetes and kind of transforms the output to make it somewhat more readable for the end user. And you have things like get, describe, logs, inspect, exec, debug, and so on, where you can interact and get information out of the objects and get like a high-level state of what is actually currently going on in your cluster environment. This has also a subset of tools which can kind of be broken down into, like, say, web-based ones, fat client-based ones, and CLI-based ones. So another factor that actually makes that observability part difficult in Kubernetes is not just that you have that different angles, also this kind of landscape of toolings is constantly changing. So I've been working on that topic for quite a while, and when I had this was one of my early slides from a talk from a few years ago, and I had totally different technologies in there as I have now. So there was Octant from VMware, there was weaveworks Scope, there was Lens, which I showed back then, but some of the open source products were not continued or deprecated. Some things turned commercial. And so this also makes it trickier for the end users like us to figure out what is the right one. There's always been the canines that I'm going to show in a second as a good friend who stayed around, stayed open source, and has been really a helpful companion. There's been things added, like, for example, Headlamp and Skooner. A while ago, we had new kits written on that slide, but we got some complaints from the people at Headlamp and said we're not actually that new anymore, so we took it out of the slide. But still, there are things which are there and that are very well maintained and we can recommend to use. So we're doing mostly a screenshot here, as I said. So this is a screenshot of canines. For the older ones in the room might still know the term of a Norton commander. So this is kind of the Norton commander for Kubernetes, like a CLI kind of browser that aggregates the information in your cluster. And if you know your key combinations well, it will definitely give you a bit of an advantage over plain kubectl. So you can sort, aggregate, dive into resources, and move around a lot quicker. This is an example of Octant. So this is web-based. It has, of course, the advantage to have a proper GUI. You can basically use your mouse. You have a navigation tree. And most of the things actually look pretty similar to that. So this is like how Lens looks like. This is like Headlamp looks like. These tools are pretty helpful, in particular also when you get started with Kubernetes, because they give you a bit of a grouping of the API objects. Like if you hear replica set or ingress for the first time, it might not be directly clear to you what this really is, but if you see here, for example, this is something which is a workload component, or this is a network component, or this is a storage component, it will certainly help you with your understanding and putting the pieces together. All right, so this is basically Skooner, which is like Headlamp in white, but yeah, it certainly has a dark mode as well. But what I'm just trying to say, they don't really have a big difference in functionality because they're totally limited to what the kubectl gives you. And, but they basically win on the side of aggregation and easy navigation. There's also one thing that I try to show during this talk every now and then. Who of you that raised their hands before have used the kubectl debug command so far? 1, 2, not many. Okay, so it's definitely worth showing. The kubectl debug command, I think, was added to the API in 1.23. And what it does, it kind of attaches an additional container to the already running container in a pod. This is not like a sidecar, which runs a separate process as a different container in the pod. It's basically sharing the same namespace. And I'm not talking about Kubernetes, but I'm talking about like Linux namespaces here. So that means you can enrich your container process with binaries that it didn't have before. This kind of is as dangerous as it sounds. I mean, you're adding some things to like an environment which was normally not supposed to be there. So it's certainly a big security risk. But on the other hand, it can be a helpful debug mechanism if you have a failing process and you know it's still alive, but you really want to capture some live information before it eventually breaks. So it's not like a functionality that you should expose to everyone in your cluster environment, but you can selectively use to help you in tricky situations. So for example, let's say you have like a distroless container that doesn't have a shell or something like that. So you really can't do much from the outside then. And with that debug command, you can just attach it and provide the functionality after the container had been started. All right, so to sum things up, the good things here are, of course, you don't need to modify or change anything in your cluster. I mean, the API is there. You can granularly configure the restrictions, but still, it's not intrusive at all. You don't have to change configurations, and you don't need to install a lot of things. Most things really act from a client perspective. But it helps a lot in understanding and also for high-level diagnosis. So you will see some things are constantly restarting, and even in the logs do not look all right. So it gives you an entry point to kind of diagnose further. But it has, of course, limitations. So you can't really see, you can't detect the ghost process. You can't really figure out, is this process running healthy? You cannot see if the two processes that are supposed to talk to each other are really talking to each other. So with that, you need to go one step further, and with that, and one thing in between before I hand over to Tiffany, there is also Prometheus and Grafana, which we initially did not have in this slide deck, but people told us you cannot talk about observability in Kubernetes without mentioning Prometheus and Grafana, so now we do. They are two components which kind of have been around in the Kubernetes ecosystem pretty much since Kubernetes exists. So the Prometheus is more like a database component, a time series database that can scrape metrics from various other applications. And Grafana is like a visualization dashboard that can do customization of dashboards where you can illustrate things on that Prometheus data that you have collected there. We're not going to go into detail on them in a standalone way, because out of the box they don't provide so much in a standalone way, but a lot of the tools that we're going to introduce later make usage of them. So we're going to come back to that. We just want to make sure you have heard it at this point. All right, so with that, giving back to Tiffany.
Okay, so yeah, basically just to talk a little bit more about that. The uncertainty of where to put it is partially because Prometheus and Grafana are actually quite useful at all these different points in time. So you could get metrics in there for your application, for instance. You could be doing it later with, we'll be talking about eBPF, but there's just a bunch of different places where it's useful, not just one. So the next part that we're going to go into is pod-based. So specifically in this, we're going to be talking about service mesh. So basically here we're going to try, and this is like part of what you saw a little bit earlier, but just like observing basically at the pod level of things. So this was a survey that HAEUSSLER did a while ago, and it was asking what features of service mesh interest you the most. And perhaps surprisingly for some people, it was actually observability. So that's pretty useful here. So to just kind of start at a lower level of things, basically, or a high level of things, I guess, but basically your base unit in Kubernetes, you have a pod, and within that pod you may have like a specific application, so you have basically a wrapper around your container. So this pod, and therefore like the containers that you have in it are connected to some sort of network traffic. And so you could also potentially have multiple apps running inside of your pod. Like you could, basically as a result, both of those are, in this example, are connected to the same network traffic. So basically everything that one container can see, the other ones can see as well. So it doesn't make too much sense to end up having it where you have two different applications that maybe perhaps have nothing to do with each other running in there. Instead, it makes more sense to basically you have your application and then you also have a proxy that you have sitting in there. And then basically this proxy can go and listen to the traffic and see what's happening, and then it can go and collect like the different network data that you have that your application can see as well. So it's not super useful if you do this for just one application. It makes a lot more sense if you end up doing it for all of your applications. Luckily, you don't have to manually go and do this for every single one. You can set it up to have it where it ends up adding it. So basically, you end up injecting a proxy into every single one of your pods, and then all of your network information is all the data that it collects is collected by your control plane. And then you can also do things like applying policies. You can do specific things with routing. For instance, you're like, hey, I want to end up having this application have like 30%, like for this pod, it gets 30% of the traffic. This other one, I want 20%, et cetera. So it's more fine-grained than what happens by default with Kubernetes. And then you can also see like how long a trip takes, for instance, and just like being able to see more information based on that. It's one of the really nice things is that it's independent of the framework that you end up using. So for instance, you could have different languages for your applications. Even if it's the same language, you could use different frameworks. So perhaps you have a Spring Boot application, you have something that uses Quarkus. Like that is totally fine and it doesn't matter. One of the things though is that you can't get app-specific metrics, but you can go and collect the network metrics. So it limits the depth of the things that you can go and see, but it makes it independent of whatever app you're running. And one of the nice things there as well is if you're like, hey, I don't actually want this. This isn't, like maybe it's taking up too much CPU memory, too much latency, whatever reason that you might have, and you decide, hey, I don't want this anymore, you can easily go and remove it, and you don't have to worry about touching your application. And you don't have to rebuild anything. It just results in your pod being restarted. So again, all of this information basically goes and feeds into the control plane that you have. So now that you have all of this information, like some people maybe like just looking specifically at metric data, but one of the really useful things is that you can end up having basically a visualization of all the metrics that you have. So this example is with Kiali. So this is just like a to-do app that MATTHIAS wrote that's in Java. So basically, you can see like there is like the direction of the traffic flow. You can see the percentage of, like for instance, where there's two different versions of the application, you can see the percentage that's happening there. There's basically just a bunch of different things that you can look into if you go and set up Kiali. We don't have every single thing that you can see there. But this is just a simple application. If you go and make it a little bit more complex, it ends up being even more helpful. For instance, in this one, you can actually see, hey, something is obviously set up incorrectly or something is going wrong with our wavefront proxy, so all the traffic there is failing. You can see all the red there. So just kind of like to summarize things, basically it extends Kubernetes for like the limitations that you have in like traffic awareness and like the shaping for that. You're basically having, within your pod, you end up having a sidecar that is running alongside of your application, and that ends up getting information on your network flow. You can't get application level metrics from this, and you don't actually have to make any changes in your configuration during runtime. Okay, so the next part that we're going to go into, so we were just talking about things at the pod level, so now we're going to be talking about node-based. One of the ways of doing that is with eBPF. Who here has heard either of extended Berkeley packet filter or eBPF before? Okay, not very many people, so I guess this hopefully will be something new for you all then. Okay, so basically, instead of looking up at the top where we had at the pods, we're looking directly at the nodes, as I was basically mentioning. So basically, eBPF is basically a low-level functionality, specifically with Linux. You have like your kernel space that's over there on the left. You have your user space on the right. Usually, the kernel space is pretty protected. It's where your kernel software ends up running. You also have a hard time trying to go and change things. If you decide, hey, I want to have this thing in Linux, you could try adding it. Maybe it won't go through, or maybe it'll be a few years from now. That obviously is not something that's going to go and work out if you're trying to build applications and such. So the things that you normally end up changing and handling are things in the user space. You can interact with it using like SDKs, libraries, and tools. And like to give like an example, it's kind of comparable to like JavaScript in a web page. Basically, like you can create your own custom code, you can run that, but you don't have to worry about like causing damage to anything that's underlying. So here's just kind of like the different levels. So you have like your containers, and then like at the base layer you have your operating system. And a lot of like the majority of the time that is running like you're using Linux. So basically, as a result, you can take advantage of eBPF since it's at that level. So it's kind of similar in some ways to your pod-based service mesh. So basically, you have your control plane that goes and aggregates all of your information, but instead of having like having something directly on every single one of your pods, you end up having an agent that you have it running on each of your nodes. Ideally, you have fewer nodes than you have pods. The other way around is a little strange, but maybe you have it that way. This is kind of similar looking. This is using Cilium's Hubble UI. And so this is also with the Spring Pet Clinic. You can see some of the same things, like you can see like the direction that traffic is flowing. You can see the different components that end up talking to each other. There are some things that you don't specifically get in here. So like you're not getting things with like response times, you're not getting throughput, but Cilium does collect that kind of information. It's just not something that you can specifically see here. So you can actually use Grafana and be able to have that type of data as well. So you can have like your response times. There is a trace that you can see, which will, on a different level, will go into traces more. But basically, you can get a bunch of different information from there as well. So the eBPF landscape has been evolving a lot. It's been around for, at least people have been talking about it more and more over the last few years. And as a result, there are a bunch of different tools that are being created out there. Like for example, some are Pixie, Deepflow, and KubeShark. If you want to see a bunch of other ones, if you go to ebpf.io/applications, you can see a bunch of different ones there. So just to kind of like do a high level, again, basically your proxy component, instead of having that on every single one of your pods, you have that on every single one of your nodes. As a result, there's like lower latency because you have fewer hops versus like having a pod in every single one of, having it proxy in every single one of your pods. It's using a low-level Linux functionality for Kubernetes specifically, and it's just becoming bigger and bigger and being used for a bunch of different things in the observability and other spaces as well. So I'm going to hand it back over to Matthias.
Okay, thanks. So as a quick question in between, so who in here is using a service mesh? Okay, 1, 2. And who of those few hands are using it for observability? None, no, maybe one. Okay. Yeah, I mean, the observability was probably not the part why service meshes initially came into place, but they certainly show here how you can use that network breakdown of information to diagnose like slow-running components. Let's say when we started with the Kube API, you could kind of use that as a sensing mechanism, just to see, is everything kind of looking all right, or is something kind of wrong? And then with the service meshes, you can start, okay, I'm going to decompose my distributed environment now and see who of them are actually looking good and who might actually need some more attention to drill down further, which would then take us to the application side of monitoring. Also, as we've just given this talk a few days ago in Devoxx France, there was some question to say, somebody asked, does it make sense to basically use a pod-based and a node-based service mesh? And as we're showing both of them here. And my answer to that was probably not. So I mean, the node-based one is kind of giving some fuel into that competition here, because it kind of makes things a little easier, as you don't have to like modify each and every pod in the environment. But having both of them in place is certainly something which you probably wouldn't do. There are integrations how you can use like Istio and Cilium together, but in my opinion, it's probably either one that would give you that level of functionality. All right, and with that, we're coming to the deepest level. So now that we know something is wrong and we have an idea where it might be wrong, it probably makes some sense to look deeper into that component and say, yeah, how can I figure out what in that component is actually wrong? And even though this implementation on that sketch looks fairly decent, there's this little agent in the app, this is actually a very tricky thing, because now we're not so much coming from the outside anymore. I mean, with the Kube API, we just acted as a client. With the sidecar, it was still like running in a different process of the actual application. This changes here as we have to place an agent into our application to figure out like details of the application from inside. Architecture-wise, this looks fairly similar. So you collect the information, send it to a database, and visualize it somehow. And this is also a tricky part in here, because there isn't only one solution to do that. If you want to go deep into like tracing and inside information of an application, you've got many different agents, you've got many different formats of how to collect logs, how to collect metrics, how to collect traces. You get different ways how to integrate all of that. And that doesn't make it a lot easier for us as consumers. Now, that's why I wanted to give a bit of focus onto one particular technology, which is called OpenTelemetry, because the goal of OpenTelemetry here is to kind of standardize observability, not only around Kubernetes, but it fits into Kubernetes as well. It's more like observability of distributed environments. And it's not like an all-in solution that gives you like fancy dashboards and everything completed. It's more like trying to standardize on the side of data collection. Because that in the past has been something that the vendors have been pretty proprietary. So, I mean, they did this, of course, for a reason. As if they know they have a certain customer and they're using their proprietary format, they can kind of force them more into kind of a vendor login. Nowadays, we're not in the world of like big single application servers anymore. I mean, we still are, but we pretend not to be. We try to move out of that. And then we have different kind of microservices, polyglot implementations, and then this approach doesn't make a lot of sense anymore, because like, what the client's going to ask for is like a holistic environment, how they can monitor everything. So this is a quick overview of how OpenTelemetry works. It basically, the central component here is the so-called OpenTelemetry collector. And this one is the sink for all the collected information coming from various implementations. So on that level, OpenTelemetry try to standardize the format on how metrics, logs, and traces are being collected. And as it's open source, everyone can either use agents that already exist or provide own agents to feed into that system. And that's kind of also where OpenTelemetry ends. So everything that has been collected can be exported to many open source or also commercial solutions. So this is kind of the new level where the various vendors compete. So how do they actually evaluate the data? How quickly can they identify things for you? How well do they aggregate and correlate which logs belong to which situation in the trace, and what were the metrics at that time? So we are not going to do any vendor pitches here. This is just about showing what the capability of that environment will look like. Now, now let's imagine I have my application and I want to monitor and figure out how I can get my agent inside. You can, of course, do this in a plain process environment. But as we have that kind of scope of Kubernetes here, we thought we'd better do it in kind of a containerized environment. So most of you have probably put a Java application in a container. So I'm not going to go into all of the details in that. So here you see like a sample Docker file where you have your base Java runtime environment, you copy your jar file in, and then you launch your Java process. The difference here is, in that approach, you kind of add, or add means download in that case, you download the latest version of the OpenTelemetry agent jar file, and then you modify the command how the Java process is executed. So you add the Java agent switch in there and point that to your jar file. That means whenever this container is started, and hence the resulting Java process is started, this kind of library will be attached and the functionality can be used. This also has, as we kind of comparing how intrusive are the various solutions, this of course means you need to modify the container to get there, but you don't necessarily need to modify your Java application. So it can still already like reuse already built jar files. Of course you can do that in another way. So first, this is like attaching the agent, and then that's the configuration of the agent. So this is like a Kubernetes container configuration where I say, okay, what do I need to give as parameters to that agent? This is like the location of the collector and a bit of identification about yourself. So I'm application X, and this is the way I'm going to appear in the collected OpenTelemetry environment. And there are many. So this is an example how you could also add it as dependencies in an application. So this is a Quarkus example. And there, of course, there's things for Spring Boot, there are things for Micronaut, there are things for, and these are only the Java-based ones. There are things for pretty much every, or the most popular programming language frameworks. They have a bit of differentiation, and we're going to come to that. The most popular ones have a thing called an auto-instrumentation. This is basically where the agent is already intelligent enough to say, okay, I want to roll out these kind of libraries, and I'm going to hook into those points because I know how that application works. For some of the programming languages, this doesn't exist. There's some kind of manual instrumentation where you really have to add things then in the code and say, okay, I want to monitor this function to basically get my trace connected in the end. Yeah, and again, same thing happening here. This is like in the properties of this application, you specify what the name is, where to send it to, which collector to send it to, and so on. So once you get the hang of it, it's pretty much very consistent of how the individual implementations for various languages work. All right, and once you're there, you are now suddenly able to query or like to display application level metrics. So this is like a custom Grafana dashboard, which has been fed by metrics that have been collected with the OpenTelemetry agent. And now you suddenly have JVM heap information, garbage collection information, threads information, all those things that you wouldn't be able to collect with either service mesh, no matter if it's Node or pod-based or anything else. So for that, you need to basically get into the app. And yeah, there's more. We're going to skip that. Now, one tool, if we talk about observability, which ties into that, is called Jaeger. This has been around before OpenTelemetry, but I think it became more popular through OpenTelemetry. It's like a framework for distributed tracing. And OpenTelemetry collects distributed tracing information, so this comes in as an open source solution hand in hand to display that. So the way this works, it kind of, and as I said, it was there before OpenTelemetry. So this, for example, is a tracing snapshot where the source of information is not OpenTelemetry, but the service mesh, like as Tiffany has shown before. And we have like a two-component application, a UI calling a backend, very simple. But you can see that with the service mesh, you can only see the entry and the exit point. You cannot see what is happening inside of it. Now, if you take an OpenTelemetry agent, that changes. So you suddenly see the insides of the application. You see like the methods being invoked, which REST calls are being invoked, the connection to the database, how long a certain service call would go, and you can find granular kind of decompose and say, this is the part of the application where things actually are going wrong. You can do this and drill this down even further. Now, I talked a bit about manual instrumentation, and there's also a thing called SDK. So you can use an SDK to implement your own configuration. So this is a Java REST endpoint kind of application, which we have seen before. So you can add some kind of string to it, and it should save it to a database. Normally, it would work with that commented out thing. So you use a repository and save it, and it goes to the database. So I commented this out and redirected it to a method that I just called some useless method, because you don't really use it, you don't really need it, but it's just something that the auto instrumentation would not catch. So if you run the thing in a way that I showed before, just adding the char, this method would not appear in your trace. But using that annotations with span would actually add it to that. So with that, you would start collecting the information from that method, and using that span attribute would actually live capture the value of that variable when the trace is being collected. I mean, very often you have the situation that a certain error occurs, but it doesn't occur all the time. So you don't know what actually triggers that. And with that, you can go deeper into the details and figure out, okay, well, it might happen only if the variable is set to this value, but it doesn't happen if it's set to this value. And then the thing would show up in Jaeger, as I've seen before. So this some useless method is now there. And if you expand it, you would be able to see the details and what has been the to-do that has been added at this point. So this way, it needs more kind of intrusion, because you actually have to modify the code. But of course, with that, you also get more details about your application when monitoring it. So to which extent it makes sense is still kind of your own choice. I mean, my recommendation is, of course, to start with the ultimate instrumentation, so it does only a subset. And if you see it's missing something, then start figuring it out piece by piece, which is the part which are really relevant to you. All right, so we are coming to an end. We have 2 minutes left. We've seen a few categories, different service mesh implementations, Kubernetes API, application monitoring, and I'm sure there's definitely more toolings than we showed. I don't think there's probably additional tooling of profiling that we haven't really covered yet. This is not what we're going to cover in the next 2 minutes, so this is not happening today. But one thing I wanted to highlight, this is something some colleagues of mine have actually implemented. It's a website called OpenAPM, which kind of lists all the various technologies in the space of the CNCF. And then you can kind of figure out what is actually compatible to what. So what can feed into which part, who can be an agent for which server component, which one would use which database. This is also, of course, open source. We're always happy if the providers contribute to that, so we can keep it up to date. Give it a try if you have the time. So yeah, to sum it all up, this is the deepest level kind of how far you can go. You get down to the method and the variable level. I don't think you can get any deeper. But in turn, you pay the highest price because you have to manually instrument all those components. But only with that, you are able to do proper root cause analysis and figure out what the problem of your application might be. So yeah, these are the categories we have seen. I mean, it's not that one is better than the other. It's more like that we try to give you a bit of an idea. What can you expect from each category? How much do you pay? What are the boundaries and the limitations of that? And yeah, if you liked it, you can now download the slides. And we'll leave that on. Before I jump back here, I will just say, yeah, 20 seconds left. Thanks for listening, and we have some time for questions.